All right, welcome back, everyone. Have a seat, get comfy. We're going to start off with coroutines and what to do and what not to do with Gerard Klijs. If you have any questions, save them until the end, because if you do them in between, they might already be covered later on in the talk. So save them for the end. We'll have some space there. Also in the chat, if you have any questions, put them in and I'll moderate them. Give me 1 second, because I'll run over with the boomstick, and you'll be audible for everyone as well. All right, have fun.
Yes, thanks for the introduction. So the subtitle is how to use Java APIs in coroutines without messing things up, because there's a lot of things that can go wrong. Basically, what you should not do in coroutine is blocking unnecessary, but yeah, how do you prevent that you're unnecessary blocking? Who am I? I'm Gerard Klijs. This is like my kind of profile website, where you can find the link to my Twitter and the LinkedIn stuff. So that's not, if you want to know a bit more about me, then that's there. I'm working for Open Web, which is basically a consultancy company. So I go to different clients to do stuff, and sometimes I get to do things with Kotlin, which I like. I've never been any Android developing stuff, so it could be that I'm saying things related to coroutines that might be a bit different with Android, and then you can ask my colleague there, Wessel, that has some experience with using coroutines with Android development. Currently, I'm working with Mendix. For people that don't know, it's a low-code platform, and the team I'm currently for is working for a solution for business events. And a small part of that solution is a bit of Kotlin code that's then calling into some Java code. So from the Java code, the Kotlin code is executed. One of the problems we kind of encountered, or that I found out before it went live, so that was nice, was that there was basically a method that would just start and just keep blocking and then run basically till the end of the application, which is all fine if you just start 1 or 2. Because it was using the default context. But of course, if you want to do it more than you have backing up threads in your default context, then at some point it won't get started at all. So I was a bit frustrated by that, and then I submitted for this conference, and then I got picked out, and then went more into coroutines and how they work. So now I maybe could solve it with coroutines, but back then I solved it just with a good old thread pool, because I was more confident with that it would work. So what I will be doing, I will do a quick introduction to coroutines. Of course, it's so large and wide that I can never explain everything about coroutines, but then at least if you're unfamiliar with coroutines, you have some idea. Some problems with blocking, why you don't want to block, especially not with using coroutines. Then something about a CLI I built to investigate coroutines, also other solutions like using a thread pool or from the main, with some clever stuff to still do a lot of work, but from Java. And then some different kind of patterns you can use with the CLI and how you can work around that with coroutines to make it not block. So if you, So introduction to the coroutines. A coroutine is an instance of a suspended computation. That's what's also in the Kotlin guide, and that's like a bit of fake. So basically, if you want to do things asynchronously, like the example I'm now using is doing the laundry, then you have to put your wash in the washing machine, wait for some time, and then when the machine is done, you can hang it up to dry. But basically, once the machine is working, you want to do other work. But once the washing machine is done, you kind of want to, so you can see me like as one of the real threads, and I want to do work for Mendix once I put it in the washing machine. And once the washing machine is done, I want to kind of get some kind of signal, put the wash out of the washing machine and hang it to dry before it gets smelly or something. So, and basically, if it's a coroutine, then there are easy ways around that to switch from that context. But if you use just the regular Java threads, it's a lot harder. So this is some formal article about coroutines that goes much deeper than I go into it now. But basically, it's you can think of it coroutines as an abstraction above threads. So there's continuation and a coroutine dispatcher, and eventually it's still run on a thread. So it's also not, you're still working with threads, and you still can handle as much as you have threads. So it's not magically give you more computing power. So some differences between a job, so that's from the coroutine stuff, and runnables that are the main Java units when you're asynchronously doing things. So with Java, if you have a runnable, you can do a thread sleep if you have to wait for some time, but then the whole thread is not doing anything, and it might need to do something in the background, but it can't. And you're really blocking that OS thread you have running. Well, if you have a coroutine and you have a job, you can use delay, and that won't block the thread. So then the backing thread is free to do some additional work. With Java, you basically always have a very flat structure. So you just have tasks, you just fire them to an executor, and then you can just wait till it's done. And with coroutines, you can have them hierarchical, which is nice if you want to cancel them. You can, for example, also cancel the children of the job. And also with error handling, it's also a lot nicer than with Java, because then you have to build some things around. Also with Java, you're working directly on the thread, so that's also causing some of those problems. And with the coroutines, you're working via a dispatcher that can help you with some of those things. So it can make it like the delay, and then put something else on the thread again. So the problem with blocking is, of course, that once the thread is busy, then it can do anything else. So, for example, even if you use thread sleep, then it can also not do anything else. So if you do blocking with coroutines, you might saturate the underlying thread pool. So for example, here is an example of the delay call that blocks for a certain amount of time before it returns. And then if your coroutine context you're using has 2 backing threads, then once you want to start a third, you first have to wait till one of the other ones is finished. So if you want starting a lot of them at the same time, then the wait time will become higher and higher. And that's just comparable to like the washing machine. If you're like blocking for 8 hours of work and you can't get any signal in between, then by the end, the wash is still in the washing machine and becomes smelly, and you have to run the wash again. So to investigate into what I can do with coroutines, what not, and how they run, I built a CLI. This you can reach from that URL. This will go to a GitHub repository. I will show some things of with the CLI. I recorded that Sunday, so I won't do any live coding like Nicolas. So I'm not that confident about it. So I just run some code. And if you really want to see the code, you have to go to the project. So I won't show any code because of time and stuff. But if you're interested in it, you can also always go to repository. The basic idea of the project is that there's a bunch of Java code that should be seen as kind of like an external API. So that just as it is, and we can change it. And then from the Kotlin code, we actually call the Java code and try to make it efficient. So what we basically want is just handle everything we do in the Java from one thread, and not having a lot of threads, or even like for every task start up a new thread, because that's limited. So in the CLI there are different actions and different run types. Now I will show a demo of it running, if internet's well and it's well. So I used a library that makes it very easy to use CLI. So you see here this output that explains what's there. So there's a lot of things you can configure and set and play around with. And now we'll run it without any configuration. So then it will use this delay of 1 second just on the main thread. So then each time it will take 1 second till it outputs an integer, and then the next one. And this is using a thread pool which will fail because I want to try it with 10,000 and it can't create a thread pool with 10,000 threads. So then it fails. So if you want to do a lot of computations, then with the thread pool it will fail. And the nice thing with coroutines is you can do that since it abstracts over the actual threads. So there are different kind of run types. So there's one is the same thread, so that will just run it synchronously in the same thread, each after another one. Then there's the same thread complicated. Then I do some kind of clever things to keep it in the same threads, but still do much more work. So for example, with futures, I would just first create all the futures, and only after I created them all, do a get on all the futures to really know once I'm completed. Then there's the thread pool, like I also saw in a demo, but which is kind of nice because you can do a lot of things in parallel. But if you have very much things in parallel, then it will break because then it just can't get those threads from the OS. Then suspended, that will just use the suspend functions. So then there are some clever ways, in this case mostly using the delay with some other stuff to make it efficient run with coroutines. And also the suspended default using the default context. So then you have the backing threads, in my case, of 12 threads, which can cause problems if you have thread safety. Because then, for example, the same kind of function might at some parts land on another backing thread, and that might cause problems, which was one of the reasons at Mendix why we used one big blocking method. And there's a few others that are experimental, like the max parallel thing that they just added in 1.6.0. So it's currently the whole CLI is in 1.6.0, so it's the latest. So when we run the CLI and we combine the runtime and the action types, we get a particular behavior. So like when we run it synchronously and it's waiting for 1 second, then the whole program takes 10 seconds and you can see how it's running. But if you use it with coroutines, it becomes something different. So one of the first pattern I will talk about is just a call, which is a single call that eventually returns an int, and you can set a delay. But of course, in the real world, you can't set a delay. So for example, there might be some networking involved, and then you probably want to set some time out and handle the error. And there's not really a way with coroutines around this, because it's just a single call. So it's basically like if we use the analogy of the washing machine, it's basically like doing really the wash yourself, because you can't run away from it. So you really have to do the work yourself and wait till it's done, and then you can hang it out to dry. So this is from the first run. So this is just the default running on the main thread, and then each time it will initiate the delay call, print out the message, then initiate the second delay call, print out the message, and so on and so on. So there's not anything parallel going on there. But with coroutines, we can do some stuff like, so this is first on a thread pool, so then it's with 10, and then it's done within a bit more than a second. So that's in this way, but like I said, if it becomes a lot of work, then you can't get all of those threads, and then it won't work. And then with coroutines, we can switch context and then use more threads if we want to. So in this case, it's run with 2. So you can see, if you look closely, that each time it's getting two of those ints every second. Since they are from the main thread, it's dispatched to another context that has 2 threads. And of course, you can increase that, and then you can do more work in the same amount of time, but still you need more backing threads. So that's this picture, yeah. So here we, so from since it's suspended still on the main thread, so it's still run also on the main thread, but then the delay call is called into the separate context that has, in this case, 2 threads. So therefore it can do more work than you would expect. And also because of this, the main thread is never really blocked, which is also nice. Then some other patterns is a feature that's, I guess most people are familiar with features from Java. So basically it's, you get something, but you're not sure once you get it. And you basically, most times in Java, you would just call a get, and then you block till you have it, and then you can do something with it, and it might also be cancelled. So this is just running it with on the main thread with features, and then it will indeed, like I said, just wait for each get till it runs the next one. And then with coroutines, we can do nicer things. Yes. So basically with coroutines, we could check if the feature is completed or not, and then do a delay. And because the delay is not blocking, we can access or walk through all the features in the same amount of time. And then what I did, yeah, suspended. So this is all locked from the main. Yeah, so there's also the complex one is creating all the features in advance, then going by them, getting them all, and making sure the work is done. But of course, this is getting more complex, which is also some of the advantages with coroutines. Like sometimes you can do the same with the same threads just from the Java way, but then probably your code will get more complex and more complex than if you would do it with coroutines. So here, indeed, so this like just running it from Java in a complicated way, first creating all the features, then awaiting all the features, and then getting them and printing them. Yeah, and this is from the in the coroutine way where we suspend and then still check if it's completed or not, and only if it's completed, we get it and we print the message. Sometimes with Java APIs, you can also provide a callback. So for example, if you use the Kafka API to produce something, and that's like a lambda that's executed once it's succeeding, and then we can use a suspended coroutine, which is even nicer, because now we are just checking each time and then having a delay, a check, and having a delay. And with suspend function, we can just get the signal from the callback and continue with our computation. That's, well, in the execution time, it will kind of behave the same, but the code behind it is much nicer and much readable than just keep checking and keep delaying. So that's nice if the API offers to have a callback. Yeah, so basically so this is what I said in the diagram. So it's creating the suspended coroutine, and just from the Java thread, it will be completed, and then it will just continue with the computation without having to check each time if the feature is resolved already or not. Then the consumer, that's kind of that's the one that was actually giving the issues with the Mendix one. It's pretty Kafka specific, but I kind of recreated it just in Java, just an abstraction with just the problems that it would give. So it's a kind of stateful class that's not thread safe. And then on the consumer, there's a poll method, and you can give it a delay in milliseconds, and then you have kind of the guarantee that it will never block longer than that amount of milliseconds. And of course, you can call it with 0, but it's not supposed to be called with pole 0, pole 0, pole 0. So then with coroutines, of course, you can use a delay again and then call a pole 0, and then it will work. And this might also give problems if you use the default context, because then the computation might continue on another thread, and then since it's not thread safe, that will give you an exception. So that was some of the things here. So I'm just running it now that each consumer just consumes 3 items and then exits. And of course, in a real application with Kafka, you probably start the consumer and then you just want to have it keep consuming for the rest of the application. So then it will keep locking. And you can see in the unsafe, yes. And now it's using the default context, and then it will fill. Yeah, so now you get an exception because it's using the default context, and then it's can end up on another default dispatcher worker, and then you get an exception because it's not thread safe. So this is the diagram with just running it in the main thread. So that of course will take a long time, because then you create a consumer, keep polling till the goal, and then create your other consumer. And of course there is a way around this, but I implemented with the main thread complicated one, but then you have to write quite some code and do some state management to keep check that once each consumer is done. So it's not really nice, and with coroutines the code is much nicer. Yeah, so this is with the coroutines. Then I'm creating the consumers, I'm polling and then delaying. And because I'm using poll with 0, it will never really block. So it will also not block the underlying threads. So that's really nice. But then of course thread safety comes into play. So one way to do is use it on a context that just has one thread, because then you're sure you're not walking against thread safety issue. So just using it with the default scope will not work, because then you get the exception that we saw. Now I can show, this is like what happened with the Mendix thing. So I'm starting 13 consumers, but because my on my local I have 12 vCPUs, so the 13th one will be executed later. So you can see from the times, like the last 3 ones, they're all a second behind, because it's first busy with the other ones. So to summarize, coroutine offer more options to make most of your threads, but and most of the times if you have, because this is not even really a complicated thing, because this is just printing out an integer, but especially if you also want to use the results of a suspended function again in another suspended function, and if you would want to do kind of the same with the Java code, you would basically begin to write your own coroutine dispatcher, or something like Eric's Java stuff kind of code, which quickly becomes very brittle and hard to read, and coroutines offer much better readability, I think. So be wary of unnecessary blocking. So for example, if you do network stuff, it might be that something is unavailable, and you might want to set a timeout or something to prevent blocking your threads and then kind of halting the whole application without really knowing what's going wrong. And if all else fails, a good old thread pool might be best, but then of course there's the question which thread pool you might want to use, and how you might want to make sure that that's all the threads are closed again. But like in our Mendix case, then it was just a few times that the action would be called. So, and since I also was more confident with thread pools in that case, I think it was a good choice, at least at that time, to go for a thread pool. So thanks. Any questions?
Got one from the chat from Vincent Free. When you explain the consumer pattern, could it be even faster using an event loop?
I'm not sure about the event loop.
Mm.
So it could be.
Yeah. Any other questions, guys? Let me get the mic over. Man, this thing is huge. All right, who's first? We're stuck here. Oh, sorry.
Yeah, I was wondering, how does it compare to some third-party frameworks? For example, for listening to Kafka, you could also use Spring Kafka. Then you don't have to do the polling yourself.
That's a good question. In our case, we wanted to keep it light, so we don't use Spring. And indeed, I've used Spring. I don't think I did use it with Kotlin before, but then without coroutines. But then at least since it's abstracted away by Spring, you don't have any problems with it. I think it's backed up by thread pool. I don't really know what kind of Spring magic happens underneath with the Java consumer from and then into Spring, but at least then you also don't really have this problem.
Does that cover it? Yeah, cool. There's one over here.
Oh yeah, essentially same question.
Essentially same question. It's good. Any other questions? No? How many minutes do we have left? 15. All right. Gerard, what made you passionate about Kotlin in the first place? What made you fall in love when you saw the language?
Well, to be fair, I'm not really fall in love with Kotlin. Like I also
You're exposed.
I think about 5-6 years ago, then I was doing some concurrency things with Java, and I was thinking, God, this is quite hard. And then I came to look at Clojure, which I know it's a Lisp, and it's like a long way from Java.
Yeah.
But still, I actually like Kotlin, or I like Clojure more than Kotlin. But I think Kotlin is like a nice alternative, especially since you can just easily combine Java and Kotlin code together. Also, there are things you need to be worried about, but that's much more easier than it would be with Clojure.
Yeah, that makes sense. Anyone in the audience want to share why they fell in love with Kotlin in the first place? Let's see. No one wants to share? I'll bring the boomstick. Give me a sec. All right. Sorry.
So given that we have some time, would you care to take us through some of this code? Because you mentioned it several times, like this code would be looks a lot nicer than the other code. I would love to see that.
Check. So the main stuff is in the util of the Kotlin code. So here, for instance, there's the kind of suspend on the polling consumer. So then it's keeping a variable for the consumed ones. And then it's doing the poll with 0. And then the delay is configurable from the constants. And those constants are configurable from the CLI parameters. And so for the feature, it's...
So how's that better than the Java alternative?
Well, if I want to do it concurrently, then I made some... Oh. Yeah, my own screen went blank, so I'm not sure. It should have enough power.
I think it's Oracle interfering.
Yeah, I don't know. Yeah. So without a code, that's a bit difficult. But at least, so if I want to do from a single thread, use the consumer one, then in the same thread, I have to really kind of keep track of every consumer that's happening, like especially because there's this abstraction is missing. Yeah, I'm not sure if that helps, since it was already at 80, so I'm not sure that's. Oh, apparently it helps. Yes, so I can see the dirty things I needed to do. Oh wait, that's in the run type. And then this is the complex. And then there's the consumer one. And then it has some messy things here. Yeah, I use several methods to abstract all the ugly code away, but you can get some kind of these. So here you have the run and next, and then it's really yeah, checking if it's already reached its goal or not, and then counting the consumed and stuff like that. So it's all a lot of kind of state management you don't want to write. And then I think I can also yeah, so this is the with the feature I'm still waiting while it's not done or not cancelled and then still delaying. Well, if I have the callback, I can use the suspend coroutine, and like I said, I just get the signal back from the callback to continue. So that's also a bit nicer, I think, than just looping. Any other questions?
Cool. No further questions then. I guess we'll round it off here. We'll be back at 10:30. So head home, head to the canteen, get a little snack. No, don't head home. For the people at home, grab some snacks as well, and we'll be back at 10:30. See you in a bit.